Hello everyone, I'm Stefan and you're watching Pixplicity Talks. Today I'm going to talk about the Android operating system. Since the topic is a bit long, it will be split into 3 parts. In the first one, I will be talking about the fundamentals of the operating system, things you should know before start tinkering with the operating system, and also when it makes sense to have a custom distribution. In the second episode, I'll be talking about how you can pull the source tree onto your computer. And finally, I will cover everything from modifying the operating system up to flashing it on a real device. So let's get started. What is Android? Well, Android is a mobile operating system specifically built for mobile embedded devices. It is completely free and most importantly, it's open sourced. In order to get to know it better, let's have a look at the Android stack. On the bottom, we have the Linux kernel. But before I tell you what the kernel is, let me give you an example of one of its functionalities. So on the bottom layer, we have the Linux kernel. And in order to understand what is the kernel, I would like to give you an example. Imagine you're looking at your mobile device, at your launcher, and you tap on an applications icon. So what's gonna happen? Obviously, the application will start. However, there are many things that happen in background. When you tap on this application icon, you're actually tapping on a device called digitizer. And this device converts your actions into a signal into information that your device can understand. So tapping on it will send a signal to the kernel with information about your touch, like the coordinates of your touch, the coordinates of the display or the part of the display you touched actually. And on the other hand, the kernel had already subscribed for such kind of events, and the communication happens through a driver. But I will tell about this a bit later. So when the kernel gets information about your touch, then it will send it to the software. And on a very high level of the operating system, your custom code will then get a callback, and the code you wrote will be executed. Or in our example, the application will start. So what is a kernel again? Well, the kernel is the bridge between the hardware and the software. Anytime the software wants the hardware to do anything, then it will send a signal to the kernel. And you see the communication is both ways. So the software sends something to the kernel then communicates with the hardware gives some information back to the kernel, and the kernel sends it back to the software. In the Android version of the kernel, of the Linux kernel, there are a couple of things in addition, including wake locks, the IPC binder, and some other mobile embedded specific features. On the second layer, we have the whole, or the hardware abstraction layer. And we know that for hardware, in order to work, we need drivers. And some of them are open, but however, they're also closed source. And the reason for that is that some vendors, they don't want to share their proprietary technology with other people. And this is a bit problematic. And in order to overcome this issue, Android has introduced the hardware abstraction layer. It's an interface that every vendor must implement. And it allows the operating system to be agnostic about hardware implementation. And thus, drivers can be written as kernel modules, and they don't need to be built into the kernel like an open source driver can be. On the third level, we have native libraries like SSL, SQLite, Media Framework, but we also have the direct virtual machine and the heart of Android, which is ART, which stands for the Android runtime. It is a fast ahead of time compile runtime and has a modern garbage collector optimized for mobile devices. On the next level, we have the application framework. There, you can find the activity manager, package manager, location manager, as well as content providers and so on. And finally, the last layer is the application layer. It includes user apps that you installed, such as Skype, Viber, or whatever, but also apps such as the launcher, camera, calendar, calculator, and so on. And with this, actually, we finish with the layers. Moving on to application fundamentals. Applications are usually written in Java code. However, they can also be written in C++. Once an application is installed onto the operating system, the operating system would assign a unique user ID for each app. Actually, each app is represented as a Linux user. It has its own virtual machine and lives in a special security sandbox. So it runs in a total isolation from any other app. However, it's possible to arrange for two apps to share the same process. So they can also share the same virtual machine. Important to note is that since Dalvik and native apps run in the same security sandbox, you must play by the same rules, whether you're writing your code in Java or C. After we covered the essentials of Android, let's talk about the Android project itself. I already mentioned the Android operating system is open sourced, and it can be found in the internet under the name of AUSP, which stands for the Android Open Source Project. And this is actually the complete software stack which is being used and available for big players like Samsung, HTC, Sony, as well as not so known manufacturers. And last but not least, it's available for developers just like you and me. And when does it make sense to have a custom distribution though? Well, for instance, you might like to change the way the operating system works. You might change the Android SDK by adding new functionality or changing or deleting such. You can also change the boot animation, or you might want to add your own apps so they can be shipped with the operating system. Or you might want to delete some bloatware, like apps that are already shipped with the operating system. You might also want to customize the user experience. You might want to change some styles to add your custom themes, or you can also customize the operating system in a way that is tailor-made for a specific business use case. For instance, you might want to have your operating system work only in kiosk mode. One very good example for a custom firmware is the Cyanogen mod. It's actually a enhanced version of the pure AUSP code. And one of the advantages is that it provides functionality beyond what manufacturers have provided. Another example is Amazon. They forked Android and created their own Fire OS by radically changing everything from AUSP and thus not following the Google's guidelines. Another example is Samsung. They added the multi-window support, which allows users to multitask by having more than one app open on the screen at the same time. They did this by complying to Google's guidelines and thus allowing them to use the Google core application suite like Google Play Store and Google Play services. And now the requirements. if you're a Windows user, then I have bad news for you, because you would need either Linux or Mac to build the Android operating system. Though it's possible to build under Windows, however, you have to use a virtual machine which is installed on top of your Windows machine. And then you would need at least 16 gigabytes of RAM, otherwise 8 will be also okay. You would also need a lot of free space on your hard drive, preferably at least 100 gigabytes. And if you have a SSD, that would be a major plus, because this would boost the performance of your build tremendously, really. And on the software side, you would also need Python 2.6, 2.7, GNU Make 3.81 or 3.82, though you should probably already have it installed. And you would also need the JDK 7 if you want to build Android Lollipop and up. You would also need Git, at least 1.7. And finally, you'd need the repo tool, which I will talk about in the next episode. With this, we finished this video. In the next one, I'll be talking about everything you should know, from modifying the operating system up to flashing it on a real device. Thank you for watching, and if you like the video, please subscribe to our channel. See you next time.